Hi students. So this is the last topic of the seventh chapter, organometallic compounds, then some organic reagents used for oxidation, bromination, etc. etc. And the last one is active methylene compounds. So what is an active methylene group? So an active methylene group is a CH2 group if it is in between two electron withdrawing groups, for example, carbonyl group or CN, cyano group or nitro group, then it is very active because the electrons are withdrawing from the CH bond so that the CH bond become partial ionic character and will have a tendency to lose H as H plus ion. So it is more labile, means the H from the methylene group is easy to remove. That means it is very reactive. Okay. So a CH2 group, if it is present in between two electron withdrawing groups, then it is known as a reactive methylene group or active methylene group. And compounds which contain active methylene groups are known as active methylene compounds or reactive methylene compounds. For example, either acetoacetic ester, both are same, either acetoacetate or acetoacetic ester. Diethyl malonate is another example, or it is also known as manolic ester, either cyanoacetate or cyanoacetic ester. Okay, these are the most important active methylene compounds. But in our syllabus, uh, we need to study only one of the active methylene compound, which is either acetoacetate or acetoacetic ester. Okay. Then one of the important phenomenon shown by active methylene compounds are ketoenol tautomerism. It is already told you that the H is more labile. So H from here moves to O. So this become OH and double bond comes here and this becomes C double bond C. That is OH would be attached to C double bond C. That is the enonic form because OH and C double bond C enol. So this is ketoenol tautomerism, but almost 90 percentage in keto form and only below 10 percentage is in enolic form mostly. Okay, so this ketoenol tautomerism is happened only because of the highly active CH2 group present in acetoacetic ester. And acetic ester, so it is can be treated as ethyl ester of acetoacetic acid. Acetoacetic acid that CH3COH. Aceto means CH3CO. So CH3CO, CH2COH is known as it is a beta keto acid or acetoacetic acid. It's ethyl ester. That is the COH le H ന് പകരം. It is replaced by C2H H5. Then it is known as ethyl acetoacetate, ethyl ester of acetoacetic acid. Okay, so this is a structure of ethyl acetoacetate. Some of the reactions are already discussed in your class, so it is I'm not mentioning it here. The enolic form, reaction of enolic form, reaction of ketonic form, okay, etc., etc. But only the important The synthesis is already discussed, mechanism is already discussed, but I will go through the synthesis mechanism and then directly moves to the synthetic applications of ethyl acetoacetate. So next one, the preparation. How can you prepare ethyl acetate? The reaction is also known as Claisen condensate. It's very important. How can you prepare acetoacetic ester or ethyl acetoacetate? By the condensation of ethyl acetate in presence of sodium ethoxide in ethanol. Okay, so here the OC2H, OC2H5 and H ethanol molecule is removed, and both are connected together to form CH3C or CH2C double bond or OC2H. This is a condensation reaction, and this condensation reaction is known as Claisen condensation. Okay, so the product is CH3C or CH2C double bond or OC2H5, and this is the mechanism. It is also already discussed in the classroom. uh, but summing up the mechanism, first one, the formation of a enolite ion or a carbon ion. So here the ethoxide ion abstract a proton from ethyl acetate to form a carbon ion. It is resonance stabilized. Then the resonance stabilized carbanion attacks the carbonyl carbon of the second ethyl acetate to form a tetrahedral carbonyl addition intermediate. Okay, so this is the tetrahedral. See, this is the tetrahedral because the four valences are satisfied by a single bond, so it will have a tetrahedral structure. That's why it is known as tetrahedral carbonyl addition intermediate. And the next step, from the tetrahedral carbonyl intermediate, the ethoxide ion or alkoxide is removed or eliminated to form the beta keto ester or ethyl acetoacetate ester. See here the negative charge with a pair of electron which move in between this carbonyl and OCA2H5. Okay, push off from here to form CH3C double bond or CH2C double bond or OC2H5. That is ethyl acetoacetate. Okay, that is the mechanism. Then the synthetic uses of ethyl acetoacetate. One that before going to that, you should know the acidity of CH2 group. It is already discussed in your class. And here this, when acetoacetic ester is treated with sodium methoxide is very basic. Okay, so here this ethoxide ion is basic, so it abstract a proton from this CH2 group. Okay, so what will happen? It becomes CH, when it loses H plus ion, it becomes CH minus. Okay, then there is an Na plus opposite ion, counter ion here. Okay, so it is sodium acetoacetic ester, right? It is converted to sodium acetoacetic ester. And this is also that it is automatic. Normally, the negative ion is in between two carbonyl groups, so it is resonance stabilized. Okay. And the next step, what will happen if we have an alkyl halide? This carbanion acts as a nucleophile, so which attacks the um, halogen, attack the carbon connected to the halogen. See, this negative attack this carbon and next left from here. So what will happen here? Simply, it was already the position of H. Okay, and here that H is replaced by now R. Okay, so this R is connected to this carbon. That means in acetoacetic ester there is a substitution of an alkyl group, so it becomes alkyl acetoacetic ester. That means when ethyl acetoacetic ester is treated with a sodium ethoxide followed by an alkyl iodide, just like a methyl iodide or ethyl iodide, it is converted to alkyl acetoacetic ester. Okay. The next one, formation of alkyl acetic esters. See, this is alkyl acetoacetic ester, but it already it now contains one more H. So when it is treated with sodium methoxide, what will happen? Normally, this ethoxide ion abstract the proton from here, so that it becomes Cn minus and Na plus. That is sodium alkyl acetoacetic ester. When it is treated with an alkyl halide, maybe the same alkyl halide or different alkyl halide R dash X, what will happen? Here, this H now replaced by another alkyl group R dash. Now it becomes dialkyl acetoacetic ester. Okay, so such manipulation can be done because of the active methylene group present in acetoacetic ester. So very important. This reaction is very important. Now the synthetic applications of acetoacetic ester. Okay, so one important synthetic application is it is can be used for the preparation of monocarboxylic acid. It is already mentioned in previous classes. There are two types of hydrolysis. One is acid hydrolysis, other one is ketonic hydrolysis. If the product is acid, then it is known as acid hydrolysis. If the product is a carbonyl compound, just ketone, then it is known as ketonic hydrolysis. That depends on the medium or the hydrolyzing agent used. See, here this is acetic ester. It is treated with the constant alcoholic potassium hydroxide. Constant alcoholic potassium hydroxide used for acid hydrolysis. The product is made acid. See here, CH3CO, CH2, COO, C2H5, HOH. That is water. It is split like this. Here also OHH is split like this. See this part, CH3CO part is now converted to CH3COH. It is always constant, same, because there is no other manipulation can be done at the CH3CO side. And here the second part, okay, the second part that we can manipulate, we can substitute this H, replace H by R. We can replace by CH3 group, we can replace by CH3, C2H5 group, or we can replace by CH3, C3H7 group, any alkyl group that we can replace. Okay, but in this case, we haven't replaced anything. When it is acid, when the acetoacetic ester undergoes acid hydrolysis, it is converted to two molecules of acetic acid and ethanol. So it is used for the synthesis of acetic acid. Okay, and see the next one, synthesis of alkyl acetic ester. Is it? Yes, it is possible when one of the active hydrogen is replaced by R, it become alkyl acetoacetic ester. So when it is hydrolyzed, normally one of the product is alkyl acetic acid. CCS3COCH2COH. This is with the sodium methoxide followed by Rx. So what will happen? One of the hydrogen is replaced by R, that is CH3CO, CHR, COOC2H5. When it is treated with the constant alcoholic potassium hydroxide, always remember how to write it. HO, that is with the CH3CO part. The next H comes over the active methylene group. Okay. Then the other molecule, water molecule, which start from HO over the carbonyl group of the ester part, then H on OC2H5 part. So what will happen? CH3COH is one molecule of acetic acid. Other one is RCH2COH. So R നമുക്ക് എന്ത് വേണമെങ്കിൽ മാറ്റാം. We can replace by CH3. If it is CH3, the product is propanoic acid CH3CH2COH. If it is C3H7, C3H7, CH2COH, that is pentanoic acid. Okay, you can synthesize butanoic acid, you can synthesize propanoic acid, you can synthesize pentanoic acid, any acid you can synthesize by replacing this R. Okay, that is the alkyl acetoacetic acid. The next one is a synthesis of butanoic acid is very easy. Only the thing is that we have to see here in the middle part we have already two carbon. See, one carbon this one, other carbon this one, and this carbon carbonyl become carboxylic acid, and other one is the CH2 part. ഇപ്പോൾ രണ്ട് കാർബൺ ഉണ്ട് ബ്യൂട്ടനോയിക് ആസിഡ് ആണ് വാട്ട് ഈസ് ബ്യൂട്ടൈൻ മീൻസ് ഫോർ കാർബൺ ആറ്റം സോ വി നീഡ് ടു ഇൻട്രൊഡ്യൂസ് ടു മോർ കാർബൺ മീൻസ് we substitute or replace the H by an alkyl group with two carbon means ethyl group. So it's very easy. First it is treated with the sodium oxide, then it is treated with ethyl iodide. So the CH2 group is substituted in the active methylene group, followed by acid hydrolysis. Condition is concentrated alcoholic potassium hydroxide. So what will happen is convert to acetic acid, then butanoic acid and ethanol. Okay, so one of the use is you can synthesize either propanoic acid or butanoic acid or pentanoic acid. Okay, but generally fatty acids from or carboxylic acids from acetoacetic ester. The next one is synthesis of dialkyl acetic acids. There is nothing. In the previous case, we have replaced only one um, hydrogen, active hydrogen. In this case, we are replacing two active hydrogens. Both active hydrogens are replaced. Okay, see here, first one R, second one again C2H5ONA and R dash X. So R dash in the place of 2H. Okay, and followed by concentrated alcoholic potassium hydroxide means acid hydrolysis. So what will happen? It is converted to R dash CH COOH, that is dialkyl acetic acid. And as an example, here this acetoacetic acid is treated with 2 moles of sodium ethoxide and 2 moles of methyl acetate. Okay. So what will happen? The two hydrogen atoms are replaced by two CH3 groups. When it undergoes acid hydrolysis, the middle part is what is the middle part? CH3, CH, CH3, COOH. This is isopropyl. Right? CH3, CH3, CH, CH3, COOH. That is 2-methyl propanoic acid. Okay, or isobutyric acid. Isobutyric acid. So you can synthesize 2-methyl propanoic acid. എങ്ങനെയാണ്? By you have to replace both the active hydrogen by methyl groups. Okay. The next one is very important. Synthetic synthesis of dicarboxylic acid. And here the first step is almost same. Ethyl acetate is treated, acetoacetic ester is treated with the sodium ethoxide, and here it is converted into sodium acetic ester, and here this is treated with iodine C. The 2 moles of sodium acetoacetic ester. This is treated with iodine. So Na and I 2 form NaI replaced. And here these active carbon atoms are connected together in this reaction. See, when this Na is removed from here, what will happen? These active carbon atoms are connected together. Active carbon എന്ന് പറയാൻ പറ്റില്ല എങ്കിലും the carbon atom of active methylene groups are connected together. ഉണ്ടോ? അപ്പോൾ CH3CO CH CO C2H5 which is connected to the second bond CH3CO CHCO C2H5. When it is then acid hydrolysis, okay, പറയാം HOH HOH രണ്ട് മോളിക്യൂളുണ്ട്. അപ്പോൾ നമുക്ക് 4 മോളിക്യൂൾ വാട്ടർ മോളിക്യൂൾ എഴുതണം. We have to write 4 molecules of water. So this part become acetic acid. The other part is CH2COOH, CH2COOH. This is known as that is CH2COH, CH2COH. That is succinic acid. Okay, you can synthesize succinic acid, that is dicarboxylic acid from acetoacetic ester. How? First, this is treated with sodium ethoxide, and one of the active hydrogen is replaced and to become a carbanion, and this is then treated with iodine. And here, the active methylene, the carbon atoms of active methylene groups are connected together. When it is then um, underwent acid hydrolysis, it is converted to succinic acid. Then another one, you can synthesize glutaric acid. The succinic acid and glutaric acid, the only difference is in between the CH2, COH, there is one more CH2. അല്ലേ? സക്സിനിക് ആസിഡ് എന്ന് പറയുന്നത് CH2COH ഇവിടെയാണെങ്കിൽ CH2COH. ആ സിന്തസിസിൽ ഒരു വ്യത്യാസമില്ല. I2 പകരം CH2I2 ഉപയോഗിക്കുക. Okay, കാരണം we need a CH2 group. So CH2I2, ഇതിന് മുമ്പുള്ള നമ്മുടെ സക്സിനിക് ആസിഡിന്റെ കേസിൽ we used iodine. Here it is replaced by di iodomethane. That is the only difference. Okay, so first step is acetoacetic ester. This is treated with sodium ethoxide. It is converted to sodium acetoacetic ester. Okay, then it is then treated with methylene iodide or diiodomethane or methylene iodide. Okay, so what will happen? It is two NaI replaced, and the carbon atoms of active methylene groups are connected through CH2 group. Okay, not directly connected. This the carbonyl. This is a carbon atom of one active methylene group, and this is the carbon atom of another active methylene group, and these two are connected by CH2. So when it is when it undergoes acid hydrolysis, the product is CH2COH, CH2CH2COH. This compound is known as glutaric acid. The next one, similarly, we can synthesize adipic acid. So, what is the difference? Succinic acid, CH2COH, CH2COH. What is glutaric acid? CH2COH, CH2CH2COH. What is adipic acid? CH2COH, CH2, CH2, CH2COH. Okay, so it's very easy. First, it is treated with sodium ethoxide, 2 forms sodium acetoacetic ester. Then take 2 moles of sodium acetoacetic ester. Then now we have two CH2 groups in between the active carbon atoms of active methylene groups. So the compound taken is either ethylene dibromide or ethylene diiodide. നിങ്ങൾക്ക് ഏത് വേണമെങ്കിൽ അയഡിൻ അടുത്ത CH2I അടുത്ത് നിങ്ങൾ എന്ത് പറഞ്ഞ എഴുതിയാൽ മതി I CH2CH2I. അത് BR ആണെങ്കിലും കുഴപ്പമില്ല. മറ്റേ കേസിൽ BR യൂസ് ചെയ്യാൻ പറ്റില്ല. ഇവിടെ യു ക്യാൻ യൂസ് ഇറ്റ്. ഓക്കെ, അപ്പോൾ ഇവിടെ എന്ത് വേണം? I CH2CH2I തന്നെ പഠിച്ചാൽ മതി. ഓക്കെ, സോ -2 NaBr or NaI. അപ്പോൾ ഇത് കണക്ട് ചെയ്തു. ദ ആക്റ്റീവ് methylene group carbon atoms are connected by two methylene groups. When it undergoes acid hydrolysis, this is converted to this part become CH2COH, CH2CH2CH2COH, and this compound is known as adipic acid. So you can synthesize adipic acid. See, first you can synthesize acetic acid. Second, you can synthesize alkyl acetic acid, dialkyl acetic acid. Okay, then you can synthesize dicarboxylic acid, succinic acid, glutaric acid, adipic acid using acetoacetic ester. The next one, you can also synthesize unsaturated acid, alpha beta unsaturated acid. So here, this is CH3CO, CH2CO, CO2H1, acetaldehyde. So there is a condensation reaction in presence of a amine, secondary amine. Okay, so here the active methylene, the H2 of two hydrogen atom of active methylene group and oxygen atom of carbonyl group of acetaldehyde is condensed together to remove a water molecule. Now this CH double bond is connected to the active uh, methylene carbon atom CS3, CEO, C, COOC2H5. Now this C double bond H is connected to active methylene carbon atom. So CS3, CH double bond. Okay. ഇവിടെ ഈ എച്ച് ടുവും ഓവും കൂടിയിട്ട് വാട്ടർ മോളിക്യൂൾ പോയി. Now CS3CH is connected to active methylene carbon. So um, when it undergoes acid hydrolysis, that is concentrated alcoholic potassium hydroxide, what will happen? The one molecule is acetic acid, the other molecule is CS3, CH, double bond CH, COOH, that is crotonic acid. That is but to enonic acid or crotonic acid. Okay, so you can synthesize alpha beta unsaturated acid. The next one is beta ketonic acid. And here's it's very easy. Acetoacetic ester is treated with sodium methoxide to form sodium acetoacetic ester, which is then treated with propanoyl chloride or RCOCl. എന്ത് വേണമെങ്കിൽ CS3 COCl ആവാം or CS3 CH2 COCl ആവാം. That depends on how much carbon atom you need. Okay, so this is treated with the propanoid. Here, this is propanoyl chloride. Now the NaCl is replaced. Now the CO is connected to this active methylene group. So what will happen? CS3, CS3, CO, CHCO, C2H5. That is the ethyl acetate part, acetoacetic acid part. And here, this CS3, CH2, CO part is connected to carbonyl. CS3, CH2, CO part is connected to connected to the active methylene carbon. When it is hydrolyzed, normal acid hydrolysis, the HO one side, then H over the active methylene group, then OH, then H. So when it undergoes hydrolysis, this is converted to CS3, CH2, CO, CH2, COOH. See, this is the COH, and this carbon is alpha carbon. The next carbonyl group is the beta carbon, that is, and it is keto, so it is known as beta ketonic acid. Okay, so you can synthesize beta ketonic acid. It's known as 3-ketopentanoic acid. The next one, synthesis of ketones. It is already discussed. Ketone hydrolysis. Okay, and here when it is undergoes ketone hydrolysis, is always written as H. Then over the carbonyl group of the ester, we have to put the O. Then the remaining H over OC2H5. That is a way of splitting. So it is converted to one molecule of carbon dioxide, the other one ethanol, then acetone. Okay, so you can synthesize acetone. Okay, by ketone hydrolysis. Okay, then synthesis of butanone. How can you synthesize butanone? So in the previous case, we can synthesize only acetone. So we need to introduce one more carbon, then only butanone. So it is very easy to manipulate or introduce a CH3 group. How? We know that CH2 group is active methylene group. When it is treated with oxide, the hydrogen is replaced, followed by treating with alkyl halide. the alkyl group is introduced on the active methylene group. And here it is butanone, we need only one more carbon. So what will happen? First it is treated with sodium ethoxide, then treated with CS3Br. Okay, now what will happen? One of the hydrogen, active hydrogen is replaced by CS3. Then ketone hydrolysis. Okay, what will happen? It is converted to CS3, CO, CH2, CS3. That is 1, 2, 1, 2, 3, 4. This is converted to 2-butanone or simply butanone. Okay, you can synthesize butanone. The next one is, how can you synthesize 3-methyl pentan 2 3 on pentan 2 on? Okay, so this is the structure. നമുക്ക് കിട്ടുന്നത് CH3CO CH വരെ ഉള്ള ഭാഗം. ഈ പാർട്ട് നമുക്ക് ഓരോ അസിറ്റോസിറ്റിക് എസ്റ്ററിൽ നിന്ന് കിട്ടുന്നതാണ്. റിമൈനിങ് പാർട്ട് ദാറ്റ് വി ഹാവ് ടു ഇൻട്രൊഡ്യൂസ്. ഇത് കണ്ടാൽ മനസ്സിലാക്കേണ്ടത് ദിസ് പാർട്ട്, ഇതുവരെയാണ് നമ്മുടെ ഭാഗം, നമുക്ക് കിട്ടുന്ന ഭാഗം, അസിറ്റോണിൽ കിട്ടുന്ന ഭാഗം. ബാക്കിയുള്ളതൊക്കെ CO2ഉം C2H2 ആയിട്ട് പോകും. ഓക്കെ, അവിടെ എന്തൊക്കെയാണ് വരുന്നത് എന്നുള്ളത് എന്ന് നമ്മൾ നോക്കണം. അപ്പോൾ നമുക്കിവിടെ പ്രിപ്പയർ ചെയ്യേണ്ടത് ഇതാണെങ്കിൽ ഈ ഇത്രയും പാർട്ട് നമുക്ക് റീപ്ലേസ് ചെയ്ത് കിട്ടണം. ഇത് ഓൾറെഡി നമുക്ക് അസിറ്റോസിറ്റിക് എസ്റ്ററിൽ നിന്ന് കിട്ടും. ഇവിടെ CS3 കയറ്റണം, അതുപോലെ തന്നെ ഇവിടെ CS2 CS3യും കയറ്റണം. അപ്പോൾ എന്താ ചെയ്തത്? ഫസ്റ്റ് സ്റ്റെപ്പ്, acetoacetic ester is treated with sodium ethoxide followed by treating with CS3Br. So normally one of the hydrogen is replaced by CS3. So okay, നമുക്ക് ആ ഒരു ഭാഗം തീർന്നു. നെക്സ്റ്റ് നമുക്കൊരു C2CH3 അല്ല, അടുത്ത് CH2CH3 ആണ്. സോ ഇതേ റിപ്പീറ്റ് ചെയ്യുക. എന്താണ്? സോഡിയം എത്തോക്സൈഡ് ഉപയോഗിച്ച് ട്രീറ്റ് ചെയ്യുക. അടുത്തത് CS3CH2Br ഉപയോഗിച്ച് ട്രീറ്റ് ചെയ്യുക. സോ വാട്ട് വിൽ ഹാപ്പൻ? ദ അതർ കാർബൺ ഈസ് ഹൈഡ്രജൻ ഈസ് ആൾസോ റീപ്ലേസ്ഡ് ബൈ CH3CH2CH3 anythyl group. ആൻഡ് വിച്ച് ഓൺ, പിന്നെ അടുത്ത് ചെയ്യേണ്ടത് എന്താണ്? കിറ്റോൺ ആണ് കിട്ടേണ്ടത്. അതുകൊണ്ട് എന്ത് വേണം? കിറ്റോണിക് ഹൈഡ്രോളിസ് H3O+, ഒരു വെരി ഡയല്യൂട്ട് പൊട്ടാസ്യം ഹൈഡ്രോക്സൈഡ് ആണെങ്കിലും കുഴപ്പമില്ല, കോൺസെൻട്രേറ്റ് ആവാൻ പാടില്ല. സോ വാട്ട് വിൽ ഹാപ്പൻ? ഇറ്റ് ഈസ് കൺവേർട്ട് CS3 CO CS3 H here CH CH2 CS3. അതാണ് 3-methyl pentan 2-on. So you can synthesize ketones. 1,3-diketones. You can synthesize 1,3-diketone. The only difference is one, we have to introduce a ketonic group. We can introduce a ketonic group only by treating with an acetyl chloride. നമ്മൾ നേരത്തെ നമ്മളൊരു കീറ്റോ ആസിഡ് പ്രിപ്പയർ ചെയ്തു. Okay, so here നോക്കുക, this is treated with sodium ethoxide. So one of the active hydrogen is replaced, which is then treated with the CS3COCl. So here this Cl and this Cl and Na plus, okay, it is removed. Now CS3CO is connected to active methylene carbon. So what will have CS3 CO CH CO C2H5. See here the CH like in the connected to CO CS3. When it undergoes ketonic hydrolysis, HOH CS3 CO CH 2, this CH2 CO CS3, that is this is acetic ester, and after the hydrolysis this is converted to CS3CO CH2, then the introduced part CO CS3. So 1 3, the positions of ketonic group are 1 അല്ലേ, ഒരു കാർബണിൽ 1 പറഞ്ഞാൽ അടുത്തത് 3. അതുകൊണ്ട് ഇതിനെന്ത് പറയും? 1,3-diketone, which is also known as acetyl acetone or pentane 2,4-dione. Okay. Then synthesis of hydrocarbons is not important. ഇത് അത്ര വലിയ ഇമ്പോർട്ടൻ്റ് ഒന്നുമില്ല. നിങ്ങൾ വേണമെങ്കിൽ നോക്കിയാൽ മതി, അല്ലെങ്കിൽ യു ക്യാൻ നെഗ്ലക്റ്റ് ഇറ്റ്. ഓക്കെ, ഇവിടെ ഒന്നുമില്ല. ഓൺ ഇലക്ട്രോണിക് റിഡക്ഷൻ ഈസ് കൺവേർട്ടഡ് ടു എന്താണ്, ബ്യൂട്ടൈൻ ആയിട്ടാണിത് കൺവേർട്ട് ചെയ്യുന്നത്. ഓക്കെ, അത് വേണമെങ്കിൽ നിങ്ങൾ നോട്ട് ചെയ്യുക. ഓക്കെ, The next one is very important one is synthesis of heterocyclic compounds. It is already discussed in the reactions of um, acetoacetic ester, the class. So here, the enolic form of acetoacetic ester. This is the enolic form CH double bond COH. This is urea. It undergoes condensation reaction followed by POCl3. Treated with POCl3, this is converted to a compound like this. Okay, a six-membered ring. Okay, six-membered ring. This is on a 4-methyl uracil. Okay, 4-methyl uracil. So you can synthesize 4-methyl uracil from acetoacetic ester. But you have to start from the enol form. The another one is acetoacetic ester, which is treated with hydroxylamine. It's already discussed in the class. It is converted to methyl isosolone. So you can synthesize methyl isosolone from acetoacetic ester. Acetoacetic ester is treated with the phenylhydrazine to form phenyl methyl pyrrosol. Okay, it undergoes some condensation reaction, then tautomerize. Then when it is treated with dimethyl sulfate, here this H is replaced with CS3, and this is known as and this is antipyrine 2-methyl 1-phenyl pyrazolone. Okay, so you can synthesize methyl uracil, methyl isoxazolone. You can synthesize, you can stop it here. Okay, no problem. Phenyl methyl pyrazole or antipyrine. Okay, so these are the synthetic utility of acetoacetic ester. Simply, it is used for the synthesis of monocarboxylic acid, synthesis of dicarboxylic acid, synthesis of unsaturated acid, synthesis of keto acids, synthesis of ketones, synthesis of substituted ketones or higher ketones, synthesis of 1,3 diketones, okay, then synthesis of heterocyclics. ഇത്രയും അപ്ലിക്കേഷൻസ് ഉണ്ടാവണം. ഇത് നന്നായിട്ട് നിങ്ങൾ നോക്കുക. Okay, it is very important both in the synthetic part and also in the uh, university examination part. Okay, thank you.